Welcome back. I'm Marcus with Aloha Mahi, here to explain the Hydrocyclone Vortex water aeration system. It sounds really complicated, but this thing is really so simple, you make one unwittingly every time you flush the toilet. All you need in order to make it, as far as either an aeration or a power generation system is concerned, is a bucket with a hole in the bottom. My last video explaining the Hydrocyclone Vortex was an application for aeration for an aquaponic system. You see over there we're using a 55-gallon barrel as the sole aeration system for a 10,000-gallon aquaponic system. It's been going that way for several months now and is working fantastic. But in the video I released about that, I got several questions on, well, how do I build one? And so that's the purpose of this video, is to explain just how simple it is to create a hydrocyclone vortex for aeration. So you see here, we have a bucket, and in the bottom of the bucket, there's a hole. So, it really is that easy. And it's the inflow geometry, so the hose you see is the water coming into it, comes in tangentially. So, for you who are familiar with geometry, you know the tangent is the straight line on the surface of the circle. But the water's coming in tangentially inside the bucket, so that as the water comes in, it hits the edge and starts to curve around. And because there's the hole in the bottom, it's going to create a hydrocyclone vortex as it fills up. So, without further ado, I'm going to turn on the hose to demonstrate the formation of a hydrocyclone vortex. I'll be back in just 1 second. Okay, it's going to take a minute to get established, but with the appropriate geometry configured, the hydrocyclone vortex is dynamically self-stabilizing. You can see it's already beginning to form here. And what's happening is the water's coming into the bucket tangentially, like we talked about. It's hitting the edge and it's curving around, and so the water spins around the circumference of the bucket, and the outflow is through the hole at the bottom. And as far as the technical specifications in order to make this work well, I have been noticing that the cross-section of the inflow and the cross-section of the outflow should be roughly the same for a low-pressure situation. I think if you have high-pressure water coming in, then you might want to have the outflow being a little bit bigger, but I need to do some more experimentation before I can really comment authoritatively on that. But from the various hydrocyclone vortexes I've been playing with, having the water inflow and the water outflow being the same cross-sectional area works really well for forming a nice stable, nice dynamically stable vortex. So once the water level fills up here just a little bit higher, I'm going to demonstrate that dynamic stability. So you see we have the vortex is starting to form, and now I'm going to disrupt it. So I'm going to mess up the vortex by swing. Here you see this is the vortex has now been eliminated. Something has come through and disturbed the vortex. However, because it's a dynamically stable system, it will recreate itself due to the geometry of the inflow, the shape of the bucket, and the outflow. So even though the vortex has been disturbed here, if you give it just a minute, it will reestablish itself. Okay, here you can see the vortex is reforming itself after it had been disturbed. It took maybe a minute, probably less than 60 seconds, for the disturbed vortex to reestablish itself. So the reason why this is overflowing is because the water coming in through the hose is coming in faster than it can go out through the hole in the bottom. So the way we can balance the system is to reduce the amount of water coming in through the hose or make the hole in the bottom a little bit bigger. So I'm going to go turn the hose off so you can watch what happens to the vortex when the inflow stops. So I've turned the hose off, so the water inflow to the system has stopped. And what you're going to notice is as soon as the water level drops below the hose here, look at the stability of the vortex. It's going to clean up the structure and the geometry, because the disturbance to the water flow of the hose here is about to be removed. As soon as the water level drops below the hose here, you're going to see the vortex clean up into a stabler, into a more stable configuration. And it's just a observation of the function of, or the geometry and the structure of the hydrocyclone vortex. So why am I talking about a bucket with a hole in it and a hose? It's a really simple thing, but it has a lot of powerful applications. I'm using it as the aeration system for the aquaponics, and it's working beautifully in that regard. And I started playing around with these systems for a micro hydroelectric power generation system. So at the farm, we have a stream that flows year-round. So instead of having a hose being the water inflow, we're going to divert some water off of the stream as the inflow on a larger system, and we're going to put a Hydroelectric turbine into the vortex. So the kinetic energy of the water is going to spin the turbine, which is then going to generate electricity. It's a very sustainable off-grid power generation system, even as far as micro hydroelectric systems go. And I strongly encourage anyone who is interested in it to look up gravitational vortex water power plants. If you stick that into any search engine online, you're going to find more information on them. There are some engineers in Austria and Switzerland that are building larger systems that are absolutely beautiful, that I intend to bring out to Hawaii as a functional educational model, and also as the aeration system I'm using it in the aquaponic system, but for anyone who's doing aquaculture, for anyone who is doing hydroponics, anyone who is trying to get air into water. This is a way to get air into water using less electricity. I have experimented with 3 different aeration systems on this 10,000 gallon aquaponic system over the last 2 years, and the Hydrocyclone Vortex is by far the most energy efficient aeration system that I've tried. It uses 1/3 the electricity of my initial aeration setup, and the dissolved oxygen has increased. With the various aeration setups, typically the dissolved oxygen in the aquaponics is around 3.5 to 5 parts per million. And after I hooked up the Hydrocyclone Vortex in the 55 gallon barrel over there, after one night, the dissolved oxygen has gone up to 6.4, and it has stayed up at an elevated level, using, once again, 1/3 of the electrical input. So you see, this whole time I've been talking, the water has been turned off, yet the Hydrocyclone Vortex, it's amazingly stable as far as how long it takes for the water to exit the bucket. That's because the effectively the centrifugal force, or centrifugal pseudo force, if anyone wants to get physically precise with it, is pushing the water away from the hole that is draining down. And it's really quite surprising how long it takes for the bucket to empty itself out once the Hydrocyclone Vortex is established. There are a number of interesting properties with the Hydrocyclone Vortex, both for getting air into water and also for generating electricity. But I'd like to hear back from you. Any questions that you have, we will answer in our in a follow-up video. We're going to try to start doing video updates on a regular basis around aquaponics and sustainable farming techniques. And we had interest in some of the first videos we're posting about the Hydrocyclone Vortex, so we'd like to hear back from you. Any questions you have, please submit to our Aloha Mahiai Facebook page. And we're going to answer as many of them as we can. And whatever questions that we find particularly compelling, we will include in a follow-up video. So have a nice day, everybody. Aloha.